All right, we're live. Okay. So today, thanks for coming. I don't know why I'm like doing a whole presentation thing as if we just started. There's no one watching the stream. But okay. So we talked about more Python stuff on Tuesday, primarily tuples, dictionaries, and loops, and we're going to try to apply those tools for a few practice problems here now. This is good because it might not seem like it at first, but these are incredibly powerful tools. And we're going to see that as we work on these problems today. So let's dive into it. First problem. There is a broken candy machine dispensing candies at random. However, the candy that you want is a Kit Kat. This is a very specific problem. Okay. Given the list of candies that is being dispensed, use a loop to go through the list. Once you stop, you get a Kit. Stop once you get a Kit Kat. I'm illiterate. And then print, thank you for the Kit Kat. Okay. That's... Okay. So are we given a list of candies that's being dispensed? No. We're not really given a list. So let's say our list of candies looks like this. Candies... oh, by the way, has everyone been able to pull up their own like version of this thing on their own local machine or on their own Colab?
No, I will try to do that right now.
Okay. This might be...
Can you hear me?
Yeah, hi.
Yeah, I have a version of it where there is a list. It says K for Kit Kat, G for gummy bears, S for Snickers, under like Q for week 1, part 2.
Oh, like this?
Yeah, is that not the list you're talking about?
I was thinking more of like a list within list
like
object in Python.
Okay.
Yeah. At least I hope I'm interpreting this question the way that it's meant to be interpreted. But my idea is that like how do I explain this? Okay, let's text edit. This is not okay. I wanted to pull up like a quick text editor so I can demonstrate what I interpret this problem to be. But okay, so I interpret that like there's this like order. We have this vending machine, right? And it's like spitting stuff out in random order, right? So like first it'll spit out like gummy bears, then it'll spit out Snickers, and we just don't have any choice. And then we'll get gummy bears again, and then maybe we'll get gummy bears again. I don't know, just have a lot of gummy bears, and then we have Snickers. And then we have, and then finally we'll get a Kit Kat, and then maybe they'll give us more Snickers, right? We don't control this. So my interpretation of this problem is that like, okay, so we have like some order that the vending machine is going to spit out the candies, and the order is not like something we have choice over. And then, so we have to like loop over some list of candies, right? And then once we get a Kit Kat out of it, then we print thank you for the Kit Kat. But in order to do that, we need like this actual order of candies that it's going to spit out in the first place, which I see that they have not afforded to us. So we're going to make our own for the sake of our exercise. Yes. Does that make sense on like the motivation behind doing this? Yes, no. Feel free to speak up as you choose.
Oh, sorry, I was muted. Yes, sounds good.
I know, you're all good. Okay. Yeah. I know like everything is up on stream right now, but right now I have like, I wish I had more monitors so I could actually see you guys as I was doing this, but right now as it is, I can't both like do this and see at the same time. So if you were willing to like unmute yourself and just speak up, I would appreciate it. Okay, great. So we're writing an order for this, right? We're just going to use the orders that we wrote down here. Gummy bears, Snickers, gummy bears, gummy bears, Snickers, Kit Kat, Kit Kat, Snickers. if you're doing this, I'm going to be honest, it doesn't really matter what the order is, right? Our program, the nice thing about programming is that it's like you can generalize, right? You can, in theory, put in any input and then like still have it do a thing, right? Like if you think about it, if you have a program that's only able to take a specific input, then it's not very useful. So the point of our programming is that we want to take a range of valid inputs and do anything with that. So really, we should be able to write a program that takes like any sort of order of candies, and it doesn't really matter. So yeah, whatever order that you choose to write down, you could go with the order that I have here, or you could not. Really, it shouldn't matter. So long as our program is like, good and does what it should do, it shouldn't really matter what the order is. But we give it here, so we're going to test our program out on it. Yeah. So anyway, let's see what we're trying to do. The candy that you want is Kit Kat. Given the list of candies that's being dispensed here, stop once you get a Kit Kat. Use a loop to go through the list, and then print "Thank you for the Kit Kat" once you get a Kit Kat. All right. Any ideas on what we should do? My first hint is this.
So we should create a loop.
Good call. We learned about 2 loops, while loop and for loop. Which one do you think we should use?
A while loop.
Okay. Why?
Because while loops are meant for going through lists like this until a condition is met. And the condition we want is Kit Kat.
Okay. So I'm going to address a few things with that answer. It's kind of a trick question because, like, in theory, the answer is that you could use either. Recall that, everything that you could do with a for loop, you could do with a while loop. That's the point we made last time. The question really is always like, which one's easier? So to your point, Livia, the way that you're talking about is like, if we write this in pseudocode, are we all familiar with what pseudocode is? It's like this idea that you don't actually want to type out every like piece of logic and every single line in code, but you kind of want to explain what your program does. So you write in this like kind of code-ish looking thing, but it doesn't actually run. It's just to explain what your thought process is. So right. So we have like some candy, right? And candy is like some empty string, right? And while candy isn't Kit Kat, right? Then, well, we can even set like I equal to 0, right? While candy isn't Kit Kat, we say candy is equal to, the ith element. Or okay, we're gonna start candy out on like the 0th element of candies, right? And while candy isn't a Kit Kat, we set candy, we increase. I'm thinking through this now. Okay, sorry. I'm live coding this along with you. Candy is equal to the ith element of candies, right? I is equal to 0, so candy starts out as the 0th element of candies, so it's G. So while candy isn't the Kit Kat, we change candy to be the next element of candies. So I is equal to I plus 1, and then candy is equal to ith element of candies. Maybe that's not the most efficient way to do it, but yeah. Like to your point, if we use a while loop in this fashion, that would sort of work, right? I got this from you saying while the whatever element of candies isn't a Kit Kat, we keep moving until the whatever element of candy is Kit Kat. Is this sort of what you meant?
Yeah, honestly, it was easier to understand on Tuesday when we were only dealing with numbers. Like I'm eager to see how it translates to something where you can't add, like if you add 1 to K, that doesn't get G and it never will. Like,
right.
Yeah.
Right. Okay. So here's my proposition. Everything that we could do with a for loop, we could do with a while loop. Sure. But I'd like to point out that, generally speaking, whenever you're working with a list or with a tuple or iterable, it's generally easier to work with a for loop than a while loop. The reason for this is because of this. If we're doing a while loop, we need this like counter variable, right, in order to access any element of candies, right? Because we need, in order to access any element of candies, we need to say candies and then some counter variable, which in this case is I, right? And then we need to like keep track of I, and then if we want to access the next element of candies while we're in the while loop, we need to increment I, which is exactly what we've done here. Actually, that's exactly what we've done here. And like that's possible, yes, but generally speaking, the for loop sort of does all of that for us for free. So if we say for candy in candies, right? This is just an example of print candy. What this will do, what the for loop says, is that it'll take the first element of candies. We don't need to keep track of any index or anything. And then it'll do whatever it is with candy. And then once we're done with this iteration of the loop, it'll just move on to the next element for us. No need to keep track of a counter. Does that make sense?
Mm-hmm.
Okay. So general rule of thumb, not always the case, but general rule of thumb, for lists, it's good to use for loops. For things that you keep, for things that you want to keep running while something is true, like if you want something to happen based on a condition, then you use a while loop. Does this make sense?
Yeah, and this is more this is like a negation. This is the opposite, where we want it to stop when something happens.
Right. Yeah. So we want it to stop when something happens. First, just as a demonstration, let's run this. There we go. Right, this makes sense. First iteration, candy is the first element of candy is G, print G, then move on to S, print S, whatever. Great. So we don't want this to happen. Stop once you get the KitKat. And yeah, we're gonna have to workshop this problem. I think there are some flaws in it, but anyhow. Yeah, so we actually want the loop to stop at some point, but we want to stop it based on a certain condition, and therefore it's reasonable to say like while loop, right? I understand the reasoning for saying that, though I personally think that like with a list, even if we do need to stop on a condition, it's easier to use a for loop just because of the presence of the list. So we're gonna need to think of some other way to stop the loop from continuing based on some condition. My proposition is this. Actually, you know what? I'm going to keep my mouth shut. Do you guys have any ideas? Stopping the loop based on a condition while the loop is happening. A hint is to think back to some of the keywords we talked about last time. Actually, it might be nice to pull up the slides. That's probably a good idea.
Wasn't there a function like continue that you use when you want the list to stop?
Cool. Almost. Very nearly. It was something that we talked about right around there.
Was it a parent?
Let's see if we can find the exact part. I'll try this. So continue is here. It ignores a specific element and moves on to the next. So continue, the idea with continue is that if I put continue here, right, I do some more stuff, right? Once the program runs the continue line, it will never do the some more stuff. Once it sees continue, it will go back up to the top. So in this case, if we think about what it does here, let's say, yeah, if it's just continue, right, it'll do whatever with the current candy. And then it'll say it is a KitKat, right? Continue if the candy is a KitKat, right? then it'll not do some more stuff. But the thing is, it will go back up and keep looking for more candy. So the loop will continue. If we look back at the prompt, it's, oh Lord. If we look back at the prompt, it asks us to stop once we get a Kit Kat. The problem with continue is that it doesn't stop. It continues. Hence the word, I suppose. So maybe the continue isn't the best option here, but I'll tell you that you're very, very close.
Is it the break?
It is the break. Well, yeah. Can you motivate why it might be the break? What can we use the break for?
Looking at the slides, the break seems to stop the loop early.
Okay. Oh, this example is exactly what we need. Cheating for us. Good for them. But anyhow, yeah. So if we do break, right, what this will do is that first it'll do candy and candies, and it'll like do this stuff, and then I'll hit break, right? It doesn't run some more stuff, but not only does it not run these lines underneath the break, it doesn't even go back into the loop. It immediately comes out of the loop, right? For example, if I do like for candy and kitties, break, and then right, without the break here, more stuff, some more stuff. It runs through everything in the loop, and then it's out of the loop. But with the break here, we only ever, first we print the first candy, it hits the break, so it doesn't run some more stuff, but it also doesn't run back into this. It doesn't run back into the loop, hence I'm out of the loop. Let's compare that to the continue, where it keeps running through the loop, but it just never runs through some more stuff. And then
So continue is just having it skip over the thing.
Yes.
Okay.
Exactly. It just skips over everything else in the loop and then restarts the loop.
Okay, that makes sense.
Yeah. Okay. So break. We're going to use break because we want to completely stop the loop. Once we get a Kit Kat, though, only once we get the Kit Kat. So it's conditional. It's conditional on if the candy that we have is a Kit Kat. How do we make this a conditional? How do we condition the break to happen only once we get the Kit Kat? Or hopefully this phrasing might be a little helpful. Break if the candy is a Kit Kat. Any ideas?
So you write like if candy == K, then colon, then break.
Like this?
So you have to put the K in quotation marks?
Yeah. I'm trying to, yeah. That's cool. Thank you. And then they also ask us to print thank you for the Kit Kat. So I'm going to do that here too. Actually, where should we put this? We need to put this somewhere, right? Because we need to print out thank you for the Kit Kat eventually. But I guess we could put it here, or we could put it here, or we could put it like all the way out here. These are our candidates, right? I'm gonna put 3 candidates here. Or I suppose we could put it after the break. So candidate 1, candidate 2, candidate 3, candidate 4. Where should we put it? And why?
I feel like it should go at the end because it's the very last task we want the program to complete.
Okay, so at position 4?
Yes.
Okay. Let's see what happens. Okay. This is why I have some slight problems with this problem, but I'm also going to print out the candy. What we get. Okay, great. So it sees the Kit Kat, it breaks, and then it says thank you for the Kit Kat. We're very polite, I suppose. Okay, that's a good call. Let me introduce to you and this is a good idea whenever you're debugging. Try to like think of edge cases. The edge case that I'm going to introduce here is that what if we don't get a KitKat? Right? What if there just doesn't happen to be a KitKat in the machine and we've been duped this whole time? Then what happens? It still thanks us for the KitKat. Then we never got one.
So
Does
it's
this-
a different position in the sequence.
Well, is there a position? Because I think you're right. I think so long as there is a KitKat, this is going to work. But if there isn't a KitKat, then we're going to get some funky results. Is there a position that can do better? That even when the KitKat is in the machine, it'll give us thank you for the KitKat right after it prints out the KitKat. But when there's not a KitKat in the machine, it won't do that. To be honest, maybe this doesn't exist. Maybe we're searching for something that doesn't exist, or maybe it does. What do you think?
We use an if else.
In what way?
If candy equals K, print thank you for the KitKat. If else, don't.
Okay. If candy equals K, print thank you for the KitKat. Else, don't do anything.
Yeah.
Okay. So I guess else. Technically, if you want to pass like else, if you want to have a block and then nothing after it, you can't do that. Like Python just won't let you. But it has this keyword called pass that basically means don't do anything. They need it because reasons. Yeah. Let me give you this hint though. So let's say the candy isn't a KitKat, right? So then it comes through, it doesn't go through this if statement, it goes through the else, right? And then it passes. How is that like programmatically different, or how is that logically different than not having the else statement there? Or is that even different? Is it different from not having the else statement there in terms of the logic?
Right, you're right. Logically, it's the same.
Right. I'll give you a hint. We don't need to construct anything. We don't need to type anything else. We just need to decide where to put the KitKat, where to put the print line. Yeah, so this is me giving hints. 4 perhaps isn't the greatest option. So we have a few more to pick from. What if we walked through what would happen if we chose to put a print line in each of the given locations?
That sounds good.
Yeah. Okay. So we could actually just see what happens. First, what would happen if we put it here? Then it'll say thank you for the KitKat ostensibly before printing every single candy. Right? This is clearly not the move. Okay. I'm gonna skip over the right answer because that would destroy the point. If we put thank you for the KitKat here, perhaps why would this not work?
Because if you put it after the break, it's not going to print.
Right. If you put it after the break, it's never going to happen. Okay. So my proposition is that you put it here. Why might this work? Or if you think that it won't work, I've been known to be wrong in the past. I am quite often known for being wrong, actually. If you think that it won't work, why won't it work? Or if you think that it will work, why would it work? Basically, what do you think will happen?
I mean, I think it'll work. In fairness, I just ran it. And it
Oh,
worked.
okay. Great. Let's see if we can predict what it does, though. So candy and candy is, we start with the first element of candy is G. Print G. G is not K. Won't do this. S is not S is the next element, so S candy is now S. Print S. S is not K. G again, not K. G, not K. S is not K. Okay, great. K. Candy is now K. Print candy. Candy is K, so K comes out. If candy is equal to K and K is equal to K, we print thank you for the Kit Kat, and then it'll break. Great, that's exactly what we want. It won't bother to go to S. Now, what if we don't have candies in there? Well, candy starts out as being G, print candy, candy is not K, S is not K, G is not K, G is not K, S is not K, S is not K. We never print out thank you for the Kit Kat. We also never break from the loop, which is good because we still need to keep going in the loop so long as we haven't found a Kit Kat. And thus, we sort of have everything that we're looking for, right? Okay, thank you for the Kit Kat. It doesn't really matter where the Kit Kat is at. We could put it in the first position if we want. We could put it wherever. Doesn't really matter. We could put it in the last position. And we could have it not in there at all. Okay. Have we answered the question? They want an exclamation point here. That's fine. Once we get to the Kit Kat, then print that. Okay. Does this make sense?
Yes.
Okay. Awesome. Everyone good to move on?
Yes.
Great. Okay. Given a list of candies, count the number of Kit Kats in the loop. Okay. Excuse me. Yeah, let's do that. So I'm gonna give a list of candies again, except maybe we're gonna add a few more Kit Kats. Oh, I got a notification, a sound from somewhere. Oh, hey Seth, you wanna come on the stream? I can't hear you, but I think you just said yes. So, great. Hello. All right. So we're working on question 5, week 1, part 2. We have a list of candies, so a list of single character strings, and now we want to print the number of Kit Kats. And let's say, essentially, the question boils down to how many Ks are in the list. Okay, I guess maybe it's cheating to tell you that that's what we're doing. But yeah, print the number of Kit Kats. I mean, okay, I'm gonna add a caveat, and we can't do this. This is not allowed. Let's pretend like the count method doesn't exist. That's my caveat here. So we have to use a loop. Yeah, if you saw this problem in the real world, the answer would be candies.count. But we're gonna try to practice using loops. So pretend like that's not an option. Great. So how might we do this with a loop? Does anyone have any thoughts? Okay. Let's go back to the slides. Perhaps there was an example here. For loop. Print the sum of all numbers, print all odd numbers. Yeah, this might actually give a good indication. This is not very easy to see, so I will zoom in on that. Actually, I don't want to touch it. This is not mine. But a good place to look for inspiration might be this line or this small example here. Yeah. Anybody? All right. So we have a list. So that's probably a pretty good indication that we want to use a for loop. The question is then what do we do in the for loop? Okay. We want to count the number of Kit Kats. So let's think about what is the thought process for using a for loop? I detailed last time that for loops make it easy for us to look at singular elements of iterables, or to look at single elements of lists at a time. So for candy and candies, this means that we only have to think about each element of candies in specific at a time. So let's actually go through a granular example. So candy is going to start out being G. We don't want anything to happen when it's G. We don't care about G. It could be anything. If it's not K, we don't matter. We don't care. In my phrasing, I said, if it's not K, we don't care, which means that we care if it is K, which is probably a good indication that we care, that we want something to happen when candy is equal to K. Okay. So there are a few hints. Does anyone have any thoughts now? Okay. So to go back to the example that we saw in lecture, this is about summing up all the elements in my list, which is not exactly what we're doing. But we're going to look at the methodology here nonetheless, because I think it's valuable. The idea here is that you have some variable outside of the for loop that's being modified during every iteration of the for loop. In this case, it's total that's being summed for every element in the for loop. Perhaps we can have something similar here. Yeah. So if it's not sum that we're keeping track of for every iteration of the for loop, what could we keep track of for every iteration of the for loop?
What do you mean when you say for every iteration?
Oh, okay. Good question. So let's actually go back to this example, and I'll blank at this. By iteration, I mean every time the stuff inside the for loop runs, right? So the first time that the for loop runs, candy is equal to G, and then it'll print candy. And that is everything inside the for loop. I commented out everything else. Let's just delete it. An iteration is an entire instance of the stuff inside the for loop running. In this case, an iteration would print out candy. And you'll notice that for a for loop, each iteration, each time that the stuff inside the for loop runs, we have a different value of candy. That is just how for loops work.
So when it runs, that's just it running, like when it runs the first time it runs G, and then when it runs the second time it runs S, or it runs GS?
It runs S.
Okay, so when okay, sure.
Yeah, it runs the next element, right? It's for candy is redefined. Here, maybe if I put it explicitly like this, candy is equal to candy. Right. So the first time it runs, candy is equal to G. The second time it runs, candy is equal to S, right? Because it's moved on. Candy has forgotten all about G. It's now looking at the next element of the list. And then it goes back to G and so on and so forth. Yeah. Does this make sense?
Yeah.
Okay. Does my phrasing of like iterations make sense as well?
So each line of candy equals is one iteration?
Yeah. So how do I put this? How can I programmatically put this? Okay, ignore like exactly what I'm writing, but this is just to demonstrate like exactly. Oh no. Why does that happen? I genuinely do not understand. Okay. Ignore the exact code that I'm writing here, but this is sort of just to like demonstrate what I mean by iteration. I think candy is print. This is the okay. So this is the okay, maybe yeah, sure. So this is the first iteration, right? The first time it goes through the loop, candy is equal to G. The second time it goes through the loop, so the second iteration, candy is equal to S. The third time it goes through the loop, so the third iteration, candy is equal to G. Then my phrasing is that the whatever iteration is whatever time it's gone through the loop.
Okay, great.
Okay. I hope that's cleared it up a little bit. Please tell me if it hasn't.
Yeah, it has.
Okay. Okay. So we're back on this question. So my hint is that we want to keep track of something outside the loop. And then we want to change it whenever something inside the loop happens. My proposition is this. What if we keep track of the number of Ks outside the loop? And then every time we encounter a K inside the loop, we add 1 to the number of Ks. What are our thoughts on this?
I mean, yeah, that should give us the number of Ks, right?
Yeah. Maybe. I mean, okay, honestly, yes. But also, like, let's pretend like let's try to trace this, actually. So we start out with 0 Ks. We assume that there are none in the loop. And then we go through the loop. So for candy and candies, we start out, candy starts off as G, right? Just for the sake of this, we're going to say print candy, and we say found a K. Right, so it'll start off as G, right? In the first iteration, the first time it goes through the loop. And then it's not a candy. It's not a Kit Kat. So it doesn't do anything. Second time, again, not a Kit Kat, doesn't do anything. Third time, it is a Kit Kat. So we do pass through this this loop. And now we print that we found a K. And now we add 1 to the number of Ks. I guess to make it explicit, we can print this out too. So the first time we find a K, the number of Ks that have been found is 1, right? And then we keep going until we come across another K. The number of Ks found now is 2, right? Because we've kept track of the number of Ks. We initialized it as 0 outside the for loop. So every time we encounter a K, it just adds 1 to it. So it makes sense to see that every time we encounter a K, we add 1 to the total number of Ks found. And by the time that we get through every element of the list, we should have the total number of Ks. Everyone cool with this?
Yeah.
Sure.
Do you have any questions, comments, or concerns? That's what we are here for.
I guess, so there's nothing that ends the kind of if paragraph. Like, so if would go on, it just loops back to the beginning of the for then, I guess.
Yeah, the thing with if blocks is that we don't like need something to mark an end with it. That's like a quirk of Python. It's that it keeps track, like it ends things and it keeps tracks of blocks through indentations, which can be kind of hard to see sometimes. But the only thing marking that we're out of the if is that there's no longer an indent here. I mean, there is an indent here, but this indent here is to mark that we're in the for loop. This is double indented. here to mark that it is both in the for loop and in the if statement.
Okay, that's new to me. I didn't realize that indents were so important.
Oh yeah, absolutely. In this coding language in particular, if you work in like Java, as I do, don't work in Java. But if you do work in Java, like it's everything gets wrapped up in like curly braces, so it's a lot more clear. Yeah. Okay. Cool. Any other questions, comments, or concerns?
Could we scroll down again to the actual
Yeah.
thing? Why is it saying, sorry, maybe this was already explained and I missed it somehow. Why is it saying we found a K and then it's like number of Ks? Or is that just counting the overall number as we go?
Oh,
Is
yeah,
there
that's the
already
suggestion we had. Maybe if I can print it out so that it doesn't say we found a K. But basically, I said every time that candy is equal to K, which is to say that every time we got to a point in the loop where the element was a K, I said we found a K, just as an explanation to say that like it passed through the if statement. We added 1 to the number of Ks, and the total number of Ks now increases by 1 every time. So number of Ks.
I see. So when it says like found 3, it's like 3 so far. Okay.
Yeah,
cool.
3 so far. That's a good addition. Number of Ks so far. Yeah, good call. Anyone else? All right. If not, let us move on. We could always come back. All right. Given an index n, if n is larger than a given list's length minus 1, then the program prints n not found. Else, it should print the value of the nth element. Then remove the nth element of the list and print the new list. Given an index n. So we're going to have to fill in n with something. No, not doc. N is something. If n is larger than a given list length minus 1, so we also need a list. And the program prints n is not found. Else, it should print the value of the nth element. So if n is greater than, that's cheating. If n is larger than the length, then L's length minus 1, print n is not found. Otherwise, print the nth element of L. Otherwise, print the nth element of L, and we also want to remove the nth element and print the new list. Okay, so let's first construct a list because it's going to be kind of hard to do without. Great.
Can I, so if I'm reading this right, what that means is we're going to give you a list, and n is just going to be a number that's an index within that list?
Yeah, n is just a number. N, a number, the index, n index of the list. Yes. Okay. So this is kind of a lot. And whenever we have or whenever we have a lot, it's good to break it down. Yeah. So first, I purposely wrote it in this way because A, it's kind of indicative of like the structure that we're going to end up using. But B, it kind of itemizes it. So if n is larger than L's length, otherwise do something. So to me, that screams like an if something else, something else. So that's where we're going to start. But so if we're going to start here, if what? So that's the first question. If what, then what?
If n is greater than, can we use, is it the len command? Is that?
Okay.
And then len, I don't know. Can we just put parentheses L in there? Does that work? Or
Okay, let's think about it. If len is larger than L's length minus 1, I guess to be clear, we should put that there. If we read back through the prompt, we're checking if n is larger than the given list length minus 1. So almost there, we just have to add that minus 1. Might be wondering why. That seems to be a weird sort of qualifier. Here's the reason why. The length of n is for, let's try to say, let's try to do print L of n. We're going to get an error. List index out of range, right? Because this is 0th element, 1th element, 2nd element, 3rd element. There is no 4th element, but we're trying to call L of 4. And if we're trying to print the nth element of L, there's no way to do it if we try to pass it the length of L. So we need to, it can't be the length of L, so we go all the way up to the length of L minus 1. Does this make sense? Okay. So that's the motivation behind keeping it length of L minus 1. So we got to do some stuff if length of L is minus 1. What do we have to do when length of L is minus 1? We have to print n is not found. Okay, that's pretty trivial. Print n is, my lord, n is not found. And already n is not found. Okay, great. But let's say n is like not. Great. Then what do we need to do? Then we need to print the nth element of L, remove the nth element, and print the new list. Okay, so these are 3 individual things that we can do, and we know how to do these. Or essentially, we can figure out how to do these. Any takers on how to print the nth element of L?
wouldn't it be print L index n?
Okay. How do we? I really can't spell the word element. Okay. How do we remove the nth element?
Is that pop? Am I?
Okay. Like this.
Yeah.
Okay. And then what? Is that it?
I think, do we need to use n again as the index?
Like this?
I think. I can't remember the pop method.
Okay, we'll return to that. And then print the new list. So what happens? Built-in function or method is not subscriptable. Okay. So generally, whenever you get this error, it's because, right. Let's recall what L.pop is. Right, it's a method. Right, it's a built-in function or method. And we had a discussion on functions and methods last time, which is to say that like they're technically objects, but like more than anything, they're processes. Whenever we try to index processes, it doesn't really do a thing because that doesn't make sense. So to say that it's not subscriptable means that we can't index it like this. But you'll recall that functions and methods, we pass in arguments to parentheses. And we should look here that we get a tooltip that reminds us how to use pop. Pop, parentheses, index, remove and return an item at index. Okay, so we do want to remove that item at n. Okay, there's a more efficient way to do this. And to give you a hint, I will leave the tooltip for pop-up. If anybody
Well,
has an idea.
I think you just said it, right? Because you said that LPOP removes and returns the thing. So
Yeah.
we could put that all in the print statement, maybe?
Like this?
I believe so.
I guess I would make that relevant. Okay. Yeah, I buy it. Cool. So let's double check that this does everything that it's asking us to do. Given it index n, if n is larger than its list length. Okay. -1. So 4 shouldn't work, n is not found, and it's not found. Else, it should print the value of the nth element. Then remove the nth element of the list, and then print the new list. Does it remove the element? It does. Does it print it? It does. Does it print the new list? It does. Indeed. Yes. I guess technically, like if you try to pass a negative element, I mean, yeah, that'll work. If you try to pass it too negative of an element, it won't. But I guess that's not really an edge case that we're really looking for now. But you know, generally in programming, it's good to keep an eye out for edge cases. Great. Everyone good with this so far?
Yes.
Mhm.
Okay. How many questions do we have? Oh, okay. I have not budgeted my time particularly well. That's on me. Okay. Create a tuple with list of your choice, but all values must be 0 or 1s. Use a tuple method to count how many ones. Okay, this one's quick. This one's quick. So create a tuple. Let's call it with T. With length L, but all values must be 0 or 1. Already I typed in not. Okay. My lord. Help. Okay. Great, there's our tuple. Count how many 1s and 0s there are. Print the number of 1s and 0s. So we're going to want to have the 1s number of 1s is equal to something. And, gosh. Okay, number of 0s is equal to something else. And then print number of 1s. And print the number of 0s. Okay. This is the stuff that doesn't really matter. The important stuff is like they want us to do this with a tuple method. I kind of gave the answer to this earlier when looking at the count problem when I said don't do that because it's cheating, because that is a tuple/list method. But does anyone recall what that is?
Sorry, could you say that one more time? Are you just asking for the definition of tuples or something else?
I'm asking for the tuple method that's going to give us the count of a certain element in the tuple.
Okay.
Let us go back through the presentation. I'll be honest, there's a lot of methods. They're kind of hard to keep track of. But if you know that they exist, or at least remember like vaguely what their names are, it's always good to like, they can always be looked up. So that's nice. I'm going to recall the tuple.count method. Use .count to count the number of times a value appears. Count 1 gives you 1. This seems like the method for the job here, right? Yeah. So let's just do that. Q.count. And we're looking for the number of 1s, and we're looking for the number of 0s. That seems vaguely about right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. Yeah, this question's pretty straightforward, but there's.
And we don't. Do we even need the variables? We could have just gone straight to print.
Oh yeah,
the
we could have.
Okay.
We could have. I did that because it is semantically clearer, but yeah, this is just as valid. Does this make sense?
Mhm.
Okay. I think I will pass along a resource to you guys. I realize there are a lot of like methods and functions in base Python, and it can be hard to keep track of. I'll be honest, we're not going to be using them like the base methods and functions anyway, too much as we go on. But they're good to keep in mind. I'll pass along a resource that's like a cheat sheet for all the base Python methods and functions, though, because it's a lot. It's a lot. Yeah.
That sounds good. Thank you.
Yeah, of course. Given the dictionary, print Jerry's phone number. What does that even mean?
Who's Jerry?
I don't know who Jerry is. Okay, this is why we're doing this, because the homework is we got to take more. I mean, right, the whole reason we're doing this is to run through our homework and make sure everything is good. This does not mean anything, unless I'm like sorely missing something. I don't know who Jerry is. I'm gonna make my absolute best guess to assume what this question is meant to be asking, and say that you're given like a phone book of a phone book of phone numbers. I can't like talk and type at the same time because either my talking won't work or I'll accidentally type in my actual phone number.
Well,
so,
then you're defining a dictionary right now, though.
Yeah, I'm defining a dictionary right now. Yeah. So you guys can, it doesn't really matter what the dictionary is. The point is we have like phone numbers, whatever. Yeah. And then we'll actually have Jerry. So Jerry's phone number is going to be this. Okay. And now we want to print Jerry's phone number. Sure. How do we print Jerry's phone number? First and foremost, how do we access Jerry's phone number? Printing it is just going to be like, we have to print however we access Jerry's phone number. How do we get Jerry's phone number from the dictionary?
We need the value, so we need his name. We'll call it by using his name. Is that right?
Okay.
So it's going to be D, and then the index is Jerry's name, I believe.
This?
I think so.
Or is it this? Maybe it's this. All right, that's not fair to me. It's this. And also this is a string. Yeah, this is a pretty straightforward question. It's directly about like dictionary indexing. Remember, to call values from a dictionary, we have to have the key, and then we just index it like we do with lists, but instead of putting in a position, we put in a key. So D of Jerry, and then we get his phone number. Yeah, this is a weird question to nail in the point, but okay. Sure. What's Jerry's phone number? Okay. Write a short paragraph on the. Okay, we're not writing a paragraph. We're gonna talk about it though. So write a short paragraph. What are the differences between lists, tuples, and dictionaries? Mention their individual use case. Okay, so we'll start out with the first part of the question. What's the difference between a list, a dictionary, and a tuple? Any ideas? Just toss them out.
Tuples are lists that cannot be changed.
Yeah, they're immutable, right? You can't go in and try to change the value of a tuple, otherwise the Python will complain. Great. How can we tell the difference visually in our code between a tuple and a list?
Lists have square brackets and tuples have rounded brackets.
Awesome.
Or parentheses.
Okay. Yeah. In what ways are they similar? This is a pretty broad question because there's a lot of possible answers.
They store data in the same way, just one can't be changed, and they're indexed in the same way.
Yeah. What is the way that they're stored exactly? Or maybe not exactly. Okay, that's a bad question.
I guess
They're stored
as
positionally.
opposed to dictionaries, lists and tuples are in a particular order.
Great. So if we're on talking about how information is stored, the difference between them, what is the differences between like list and tuple then and dictionaries? Aside from like the lack of ordering in dictionaries.
Dictionaries are about creating key value pairs.
Yes. I'm really happy you use the phrase key value pairs because that comes up a lot. Anyone else? Similar question, maybe. How can we tell the difference in our code between if something is a list or a dictionary?
Dictionaries have curly brackets.
What else sets them apart? This is true, but what else sets them apart?
Well, they're also in pairs, so they have like colons.
Yeah. Yes. And the differences in indexing, as we've just gone over, what's the difference in indexing between lists, tuples, and dictionaries?
You have to know that key value ahead of time. Whereas with a list or a tuple, you can just call it by an index number.
Sure. Yeah, you can, to index something from a list, you need to call it by its position, or you need to index by its position. To grab an element from a dictionary, you need to index by the key. You don't need the value. Ostensibly, I guess you're trying to get the value. But yeah, so you need the key. All right, so that's the first question. Mention their individual use cases. When would we use a tuple over a list? I mean, they're just like immutable lists, right? So what's the point?
I mean, I could imagine a scenario in which you were working on a complicated project and didn't want things to be able to change and move around. So if you purposely want something immutable.
Yeah, good. Something that you'll see often in like bigger projects is that you'll see like people labeling variables with like all capital letters, and then they'll do like whatever. In some instances, I'll see like a good example for tuples is origin. Origin, right? 0, 0, right? And the reason this is nice is that anywhere else in your code, right, the origin doesn't change, and it will never change. And since it's a tuple, it's not going to change. But instead of every time having to type out 0, 0, this doesn't generalize well, right? Because sometimes you want your origin like across your code to change. Sometimes we're like changing our entire frame of mind, and you go back through your code and you're like, now I don't want it to be 0, 0. Now I want it to be like 10, 10 or whatever, right? But you don't want it to change over the course of its running. You only want it to change when you go back and change it. So instead of typing in 0, 0 every time, they leave it as like origin in all capital letters, and they'll type it as that. So not only do you not have to remember that the origin is 0, 0, because sometimes it might not be when you don't want it to be, but now if you want to change origin throughout your entire script, you just go up to one point and change it. And generally, syntactically, you mark that these variables with all capital letters. Is that even how you spell origin? I don't know why. That just looks wrong to me. Yeah, I'm going crazy. Okay. Yeah. Anyway, tuples. Don't want to change them.
Wait, but so when you do go back and change the original origin from 0, 0 to 10, 10, that will then change it throughout. Like every time you wrote it in the code, it will then be changed, right?
Yeah, exactly. And that's why it generalizes particularly well, because if for some reason you wanted to change it throughout your entire script, you could do that in one swoop. Rather than like every time you reference this 0, 0, you have to like find 0, 0 and like, dig through that. What is this? Okay. Oh, that was us earlier. Okay, so yeah, that's kind of the idea. Sometimes we just don't want things to change. What about when would we rather use a dictionary rather than a list or a tuple?
If we have two things that we want to keep associated with each other.
Yeah. Let's go back to the phone book example. If we wanted to try to do this with a list, right? It's just going to be like a collection of phone numbers with like they're not associated with anyone. So you just have a list of phone numbers. We don't have any associations between name and phone numbers, and that's just like less useful. So in that sort of instance, we'd want a dictionary. Cool.
Or we could do that with two tuples, right? That were in the proper order.
Yeah, in theory you could. It ends up being kind of a pain to make sure that everything is kept track of. But in theory you could. You'll see as we go on though that we're gonna end up making first and foremost, like if you have two tuples, right? It doesn't matter. D1, D2, right? And D1 contains names and D2 contains phone numbers. Good luck trying to add a new entry into either of these. But you also have to make sure that your code is keeping track of the order, and then if anything ever shuffles around, which is more prevalent, lists and stuff, it's weirdness. And it gets even more weird when you think about nested dictionaries, right? So you have, and this is a non-trivial case, right? You have Alice, and then you might say phone number is equal to, right? And address is equal to, right? And suddenly this is just yeah, I guess in theory we could have a bunch of coordinated lists and tuples, but why bother? This is just a way better way of looking at it. Yeah. If you really do some deep dives into computer science and data science, you'll see something more general that looks like this called JSON files, or JSON, called JavaScript object notation. And they also just keep track of key value pairs just like this. And that's beyond the scope of Python. So this is a real deal. Anyway, yeah. Real world, that can be okay. So we talked about phone books, sure. Okay. Everyone okay with the motivation for list tuples and dictionaries?
Mm-hmm.
Okay. We're gonna move on. Oh, is this the last question? Wow. Look at that. Okay, look up an example of a base Python function we haven't covered in class. Remember that a base function means it's built into Python, so you don't have to import any modules to use it. After you've picked your example, write in your words what the function is, what it does, how many parameters it has, what each parameter contributes to the working mechanism. Write a short code sample where you use that function. Okay, that's fine. So I guess let's look up some base Python functions. Yeah. Okay. So here's the documentation. Anything stick out? I might have to veto some of them because some of them are a little more complicated than others. But anything looks super exciting?
What does OCT do?
Okay, oct. Good question. So let's see what it does. Convert an integer number to an octal string prefixed with 0O. The result is a valid Python expression. If X is not a Python integer object, it has to define an index method that returns an integer. For example, if you want to convert an integer number to octal string, either with prefix 00 or not, you can use either of the following ways.
So why would I want an octal string?
It's a good question. Let's certainly there are reasons for it. An octal base 8. Sure. So sometimes it might end up being the case that this is gonna like dive into some computer science theory that perhaps is A, beyond the scope, and B, I don't want to say the wrong thing. But sometimes it's nice to be able to assign like okay. Generally, when we have like higher bases, I don't know if you're all like familiar with like base whatever in mathematics, right? But think to like the idea of hexadecimal, right? Hexadecimal is a way of writing numbers that involves letters and numbers. A good application of that is to provide like names for things, right? Sometimes a good way to name things, and this will come up later in the lessons too, but sometimes a good way to name things ends up being like a long string of numbers, right? Because like if we want to give everything a different name, we can just like add 1 to each number, and that ensures that like everything is of a different name. And like large incrementing numbers is a good way to name things. But you'll notice that like this is, I mean, as much as the numbers get higher, they become like less and less easy to like parse. What hexadecimal, and I assume the octal strings do as well, and this is just one use case. I'm sure there are other use cases, but numbers in higher bases end up representing numbers with fewer characters. Hexadecimal, for example, will use letters to represent like higher numbers, and like mathematically there are ways to represent really big numbers with way fewer characters in higher base notations. So that's why you'll see a lot of like hexadecimal, octal sort of stuff in like computer things. That is like a loose motivation. I don't want to say anything too definite, but that might be a motivation for using octal numbers. That's kind of higher level. It's not super within the scope of what we're talking about, but that might be why you use that. But for our sake, oct is a pretty simple function. So let's try to apply it. What are we trying to do with it? What are we trying to do with it? Okay, first, okay, is this a base function? Is it built into Python? It is built into Python. I Googled it. Write in your words what the function is, what it does, how many parameters it has, and what each parameter contributes to the workings of the function. Okay, so what does it do? Okay, what does it do? Well, it tells us what it does. It converts a number to an octal string prefixed with 0. I don't know how else to put that in our own words. So instead I'll ask, does this make sense, what it's doing? I guess the idea of what, yeah, sorry, go ahead.
I still don't really understand what an octal string is.
Okay, I think motivating that, I think explaining what an octal string is it involves a good bit of math. I don't know if it's worth the time to parse the mathematics of it right now. Perhaps if anyone's willing to stay over to talk about, I'm personally a math major, so if you're willing to talk about the math after we stay over, then feel free to stay. But I'm sorry, Seth, I might veto that in favor for another function.
I just picked it because it looked the cutest. So
that's, you know what, that's fair. Let's look at one that is. How about we do? Yeah, you know what? Let's do round. That's not too bad. Okay. Return number rounded to n digits precision after the decimal points. Okay, great. So round does exactly what it does on the tin, right? It rounds some number to however many digits. Does this make more sense than Well, does this make sense?
Yes.
Okay. Okay, so that's what it does. How many parameters does it have? Maybe it's not super clear when looking at this. I mean, being able to parse documentation is definitely a skill to pick up, and it's going to become even more important to pick that up as we go on. But perhaps this is your first encounter with documentation. So let's try to read it here. Round. So this is the name of the function, and this header suggests that it takes a number and it takes an optional parameter and digits. So that sort of answers the question there. It has one required parameter, which is numbers, and then one optional one, which lets us tell Python how many digits we want to round it to. Okay, I gave the answer to that question. I apologize. But does that make sense?
Mm-hmm.
Okay. And what does each parameter contribute to the function? So in this case, how does either number or n digits let the round function do its job?
I mean, number is the thing being rounded, and then .n digits is the point to which it's being rounded.
Yeah, exactly. It's exactly what it says right here. Built-in text supporting round values are rounded to the closest multiple of 10 to the power minus n digits. Great. Okay, write a short code sample where you use that function in some way. So round. Ooh, no. Okay, so we're gonna print out whatever we get. So round. Why am I typing that? That's not even close to a word. Okay, so here's a nice little tooltip. Okay. So someone give me a number to round.
236.
236. So let's see what happens right here. 236, right to itself. What if we want to round it to, what if we wanted to round it to the tens? What could we put in for n digits? Well, let's go back to the documentation. Squaring round values are rounded to the closest multiple of 10 to the power of minus n digits. So if we want to round to the closest power, if we want to round it to the tens, minus n digits, well, the tens is equal to minus -1 n digits. No, sorry. 10 is equal to minus -1. Sorry, weird math bit there, right? -1 is just +1. So rounds to the closest multiple of 10, we have to give -1. Right. Does this make sense?
Mm-hmm.
Okay.
Yes.
Great. Let's like do this. And then if I said perhaps that, what do you suspect the answer is going to be? Or what do you suspect it'll print out?
From what I remember of high school math, it would double it.
When you wait, like it'll print out 452.468.
Oh, we're doing it by the by bases. Then I don't remember that aspect of math.
Yeah. So we're just rounding here, right? Like it says whatever we're rounding to how many digits. N digits says that we're rounding to 10 to the -2 power. So if we're rounding to the closest 100th place.
Wait, a -2 or +2?
Ooh, yeah. Okay. So we refer back to the documentation. Values are rounded to the closest multiple of 10 to the power of minus n digits. So n digits here is positive. So it's rounding to the closest power of 10 to the -2. Right, before it was -1. So we're rounding to the closest 10 to the -1. Right, but now we're talking about 2. It's 10 to the -2.
So 236.23.
All right. Cool. We'll do one more just for kicks. Negative 5.455. What is this going to give us?
Negative 5 point. I guess 506.
506. Why 506?
Wouldn't it be rounding it up?
Yes.
At
So
math?
rounding.
Oh, so yeah.
But would it
Yeah,
even
to .5. So
Yeah. So this is perhaps me being a little tricky.
or maybe it's negative. Yes. All right.
Yeah. So the reasoning it's this is that we're rounding to the closest 10 to the negative third power. So this is going to be to the closest thousandth. Our thousandth place is 5. So we're rounding it to the closest this position. We're already there. So there is no rounding to be had. If I had done this, then that's probably a little closer to what Seth, you had suggested. Okay. Does this function make sense? This round function is not super important. I'm gonna be real, but it's nice to have a knowledge of how to like learn how functions work, because we're gonna learn a lot of functions and we're gonna learn a lot of methods. So this is kind of an important skill to pick up.
Sorry, can you go back to the text that described what it was for a sec?
Yeah.
That looks like a different notation to me, though, where they're using square brackets.
Mm-hmm. Yeah. So, generally, when it comes to documentation, when stuff is in square brackets, they don't actually mean put it in square brackets. You'll never be putting stuff in. Actually, I don't want to say that. Yeah. Generally, when in the documentation they're putting stuff in square brackets, they mean that it is optional. Right?
Okay.
Because we don't actually have to put n digits here. The function will still run even if we don't. It might not do what we want it to, but it'll still run. But n digits is optional, and so if we do put that in there, it does do that. And we don't even need to specify that it's n digits. The argument
okay.
is
So
what's
it's in
called-
round. Okay, cool.
Yeah. Good question. Good question. Thank you. Some examples that might help. Yeah, it's always nice when documentation provides examples to see how it looks. So look for examples when reading through documentation. Yes. Any other questions?
Is it going to work on my octal numbers?
Is it going to work on your octal numbers? Gee, let's find out. Hey, look, there's an octal number. There's a negative octal number for you too. So yeah, oct doesn't take any other arguments other than x though. So yeah, there's that. Right. So before we end off here, I want to remind everyone to, if you could, take some time to fill out the Airtable survey that we put out. We'll repost the link to that. That would really help us out in making this curriculum stronger and get your opinions on it. Although I feel like being here and giving these lessons and lectures, I feel like I'm learning a lot about the curriculum as is. So, yes, I would appreciate if you guys took the chance to do that. First thing. Second thing, we're going to be diving into like some data science stuff next week. Up until this point, it's been like Python in general. Next week, we're going to start working with data. So just to prepare you guys, it's a lot of like functions and it's a lot of stuff to remember. But it's going to be good because we're here for data science.
And where were you going to link the cheat sheet that you were talking about?
I'll put that right in Slack. Yeah. So that'll be a cheat sheet for Python built-in stuff in specific. We're going to come to you guys with another cheat sheet that we have prepared for data science modules, packages in the future. So yeah, that's that. I don't know if anyone's interested in staying behind and listening to me talk about math for 15 minutes with respect to octal numbers. But yeah, thank you for coming. Please fill out the Airtable survey. If you want to talk about math, I'll be here. Yeah, that's mostly it.
Awesome. Thank you.
Yep.
Thank you so much.
Of
Have a good
course.
one, y'all.
All right. Take care.
Thank you.
Yeah.
Yeah, I'd love to hear some more about octals.
Oh boy. Okay. All right. Let me pull out my drawing tablet. This is going to be more math than it is going to be computer science because frankly, yeah.
You're muted.
This is going to be more about the math than it is going to be at the computer science. But we're going to talk about Shreya is gonna probably not be very pleased that I'm talking about math. Sorry, Shreya. Yeah. So here's the deal. Let me share a different screen. Windows, Microsoft Whiteboard. So the deal is when we write numbers like 1, 3, 5, 7, 9, what is this number actually? Like, right? What this number is, what we're saying by 1, 3, 5, 7, 9 as a number is we're saying 9 times 1 plus 7 times 10 plus 5 times 10 squared, or 5 times 100 plus 3 times 1,000 plus 1 times 10,000. That's a lot. We don't, okay, well, anyhow, right? This is what we mean. Another way to write this is 1 times 10 to the 4th plus 3 times 10 cubed plus 5 times 10 squared plus 7 times 10 to the 1st plus 9 times 10 to the 0th. And if we decide to add decimals, right, this is plus 5 times 10 to the negative 1 plus 3 times 10 to the negative 2. Right? So this is, whenever we write numbers, we're actually shorthand. It's actually shorthand for this like terribly long expression. Right?
Yeah, that makes sense.
Yeah. So the question is like, why are we so insistent on using the number 10? Well, essentially it's because we have 10 fingers. But we don't need to do that, right? So a really common thing that you'll see, let's use like a way smaller number. Let's say number 12, right? What if instead of using 10, we use some other numbers, right? We use 10, therefore we call this the base 10 notation, right? But instead of using 10, let's say we're going to use base 2 now. Base 2, which is just another way of saying binary. Right, so 12 in base 10 is equal to, something, let's call it a times 2 to the 0 plus b times 2 to the 1 plus c times 2 squared plus d times 2 to the 3rd plus d, forgetting the alphabet, 2 to the 4th plus f times 2 to the 5th plus dot, dot, dot. And obviously from like, to the 4th is what, 16? From 2 to the 4th onward, 2 to the 4th is 16. Obviously, from here onward, like E, F, G, H, it's going to be 0 because that's already too big. Which means that this is just equal to A times 2 to the 0th power plus B times 2 to the 1st power plus C times 4 plus D times 8, right? And now we solve for whatever this could be. Oh, right, here's the other rule. In base 10, how many like 1-digit characters do we have? Like all of these numbers that are being multiplied to 10 and stuff, they're all 1-digit numbers, right? And we only have 10 1-digit numbers, 10 1-digit numbers, which makes sense because we have 0 all the way through 9.
And then once we run out of 1-digit numbers, that's when we start whipping out the new digits. So by that end, in base 2, or binary, we have 2 1-digit numbers. And what are these 1-digit numbers? It's going to be 0 and it's going to be 1. Does this follow so far?
Yeah, no, that totally makes sense.
Yeah. So A, B, C, and D can only be either 0 or 1. So in order to calculate this, we say, okay, what is D equal to? Well, it's something times 8. 8 fits within 12. So let's say that D is equal to 1. Well, then now we are left with 12 is equal to A times 2, 0, plus B times 2 to the first, plus C times 4. And this is D, right? So now 4 is equal to A times 2 to the 0 is just 1, plus B times 2, plus C times 4. Now we can say, okay, let's say C is equal to 1. And you can probably see where this is going. And now 0 is equal to A times 1 plus B times 2, which means that A and B have to be equal to 0. And therefore, we have that A is equal to 0, B is equal to 0, C is equal to 1, D is equal to 1. So 12, written in the base 10 notational system, which I'll write as this, 12 in base 10, is equal to 1, 1, 0, 0, right? This is D, C, B, A, in base 2. Cool. Does this make sense?
It does, so far.
Great. So what about octal numbers, you say? Well, octal, then, is just base 8.
Got it. Okay, and that would make then hex base 6. No, we also saw a hex number. Okay.
Base 16.
Okay.
Yeah. You might be wondering, okay, well, if it's base 16, then we have to have 16 one-digit characters. And we just don't have 16 one-digit characters. Where are we getting the rest from? Well, the 16 one-digit characters in base 16, aka hexadecimal, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 of them. A, B, C, D, E, F. And that's why whenever you see hexadecimal numbers, sometimes you'll see like A, F, 2, 3. Right? You'll see a mix of letters in there. Cool. So, yeah.
That's really cool.
I'm glad you think so. Yeah, there are 2 people on stream just watching me talk about math, despite this being about data science. I'm okay. So that's that. Do you have any questions?
No, I really appreciate you taking the time for that explanation. That it makes a lot of sense.
Of course. And so therefore, just to give you back to the motivation, you'll see that like, base 12 is or base 10 ends up giving a way more compact way to represent the number 12 than base 2 does. So it kind of that's kind of going to show you that like the higher bases that we have, the shorter the representations are, right, of bigger numbers. But it also means the more one-digit characters that we need to keep track of. So people decided, okay, 16, that's a good place for us to like represent big numbers with as few characters while minimizing the amount of one-digit characters we have to keep track of.
And so hexadecimal is it's primarily in coding and stuff. You're not using this in math. I mean, math outside of computer languages.
I mean, I am but a sophomore, so I don't want to make broad claims. There are definitely people in number theory studying like base whatever. But as far as I can tell, people aren't like people understand the mechanisms of base notations. So I don't think people are really rigorously studying this still. I don't want to say that for certain though, because maybe they are. Because I don't think too much about number theory, and this is definitely within the field of number theory. Number theory. Yeah, number theory is weird. Yeah. Cool. Anything else?
No. Hey, thank you so much.
Yeah, of course. Take care. All right. Thank you to the 2 viewers on Twitch who, yeah, I'm going to call it here. Have a good night, everyone.